works better. So I'll maybe shut this one. So it, yeah, sorry. And so yes, been working in the research, higher education and research environment for the past 20 years, and been working with Ceph since 2014, since Ceph Hammer. So just before my talk, please allow me as a Ceph ambassador to recognize the excellence of Indian engineers in software development, and to thank you all for commitment to the Ceph project. So yeah, congratulations and thank you. So today my talk will be focused on Ceph S3, dynamic placement and optimized retention. So we'll go through different points, storage classes that you may know of, placement targets and pools, dynamic placement with Lua scripting, optimized retention for lifecycle policies, thanks to lifecycle policies. And we'll show the setup, the config to set this up, and we'll have a quick demo if the mobile data plane of Gaurav is good enough. Regarding storage classes, we can have multiple S3 storage classes in the Ceph cluster, linked to different pools and data placement schemes. Compression can be used. For example, I mentioned here Intel QAT if you need to offload the compression work to some hardware. It allows S3 clients to place objects based on criteria like performance, expected performance, access frequency, durability, and cost. So S3 clients select the storage class upon writing an object, but they sometimes choose incorrectly or fail to specify one. So here comes dynamic placement. What if we could choose for them? So when the client does not specify the storage class that he wants and or incongruously forces it, we could automatically assign a storage class to an object based on the object type, for example, its extension, MP4, data, PDF, whatever you want, the object size, whether it's lower than a certain size or more than 1 megabyte, for example, the tenant name, the bucket name, and the upload method. Would it be multi-part upload or single put command? Storage efficiency and access performance would be ensured right from the moment the data is written. So here comes Lua scripting. S3 gateways can execute Lua scripts on the fly when the clients try to put the data, and in different contexts: the pre-request, post-request, background, get data, put data. So those are different ways of running parts of the request where you can run Lua scripts. These Lua scripts can read and modify objects metadata on the fly. Therefore, we can dynamically set or modify an object storage class upon writing according to certain criteria. So where Lua scripting can help? Well, solutions, it can help with applications or solutions like expecting uniform performance of the storage, regardless of the size and the number of objects they send to S3 buckets. Typical example of that is Veeam backup and replication. Veeam backup and replication stores data objects from 1 megabyte to 8 megabytes, and also store metadata objects in the same S3 bucket. For index, backup index, logs, pointers, and these are really small size objects from 0 octet to like 64K objects. So Lua, where Lua can help is it can direct small objects to replicated pool and bigger ones to EC pools. Lua scripts could also provide some additional protection layer with beyond bucket ACLs. For example, by blocking requests based on specific criteria. For instance, this could enforce read-only or write-only access on public S3 gateways, ensuring that data confidentiality, even if ACLs are misconfigured. So my colleagues Emin and Marcel have been working on this and submitted a PR to allow this. Other use cases are described on Ceph documentation, Ceph website, or Ceph GitHub, I'm not sure. Like, for example, to trace requests for a specific bucket, apply default metadata when not specified by the client, so you can enrich somehow the metadata of an S3 object. You can also use it to log operations only when errors occur. So that would be interesting, and also capture operation traces for analytics. So yeah, what about Lua performance and reliability? So what about Lua's CPU and RAM consumption? Well, we've made initial tests at Clyso that showed that Lua does not add significant latency. That most of the time that's tens of microseconds. So the execution of a script can use up to 120 kilobytes of RAM per context, but you can change this value based on this new settings in Ceph S3. What if the script fails on a timeout, which by default is 1 second, or a syntax error in the script? Well, the script failures are non-fatal for S3 client requests. So the client receives a normal response as if the script wasn't applied at all. Yes, and this also regarding the performance, there's this improvement that was merged last week to improve performance by caching the Lua bytecode, which also reduces the number of network calls to read the Radius object containing the Lua script. So then we could, thanks to Lua script, you could decide to place the object depending on its size, for example, in specific pools. And now comes optimized retention. So regarding optimized retention, transition, like the ideas of lifecycle policies is to transition objects based on between storage classes based on criteria like days, or new criteria like recently that came up in Ceph S3, which are object size greater than or object size less than. So even if you didn't use Lua scripting to at the moment the data was written, you could still use these criteria to decide whether you want to move some data to an erasure-coded pool or a replicated pool. And also you could use them to simultaneously compress or decompress the data transition, which was added to the Ceph code this very week. After we've been discussing this with Casey and Matthew Eller added this. So this is a good example of community work and fast community work. We thought this was like somehow a bug, that the compression was not respected when the transition was not an object transition from one storage class to another compressed storage class would not compress the object. So if you want to scan this link, if you go to this link after the presentation, you might get to this discussion on Slack with only like maybe 8 or 10 messages. And yeah, a new fix by the end of the day. So you could use also lifecycle policies to expire non-current versions while returning a defined subset of objects of a version, versions of an object. Automatically purge stale or incomplete multi-part upload parts. And lifecycle rules can be applied selectively using tags or prefixes. So you decide which object. Yeah, sorry. So, for example, this rule to the right moves objects to deep archive storage class mapped to an EC8+3 pool after 30 days. It also cleans up multi-part upload parts after 10 days and deletes objects after 365 days. So I just want to mention that you should be careful with this because it will for sure erase your data. So if you're using versioning, you might prefer using expire a certain number of versions of your objects. So you keep one at least. So regarding your configuration, we can do this by creating a few different pools with different erasure coding profiles. And then you would just have to use the Radius Gateway admin zone group command to add these new different storage classes to the zone group. And you could also set up a specific storage class for new objects being uploaded. So then with the new storage class, you could also bind them to the different pools that you've been creating, replicated, erasure coded pools, and also decide whether you want to use compression for the objects uploaded or transitioned to these storage classes. You can, okay, so there's also this command that you can use to verify the configuration. Regarding the application of the Lua script, so there are two things with Lua scripts here there, and this kind of auto tiering. So the tiering can be made based on rules, like you remember I mentioned criteria, using criteria. So you would just, like, for example, create this configuration of the RGW service, and then in the very configuration, add the different rules that you want to use. Or you could have this being set more dynamically. You would just make a reference in the RGW configuration to a local file system that you would put on the Rados gateways, and you could edit this rule configuration files. These rules configuration file directly on the Rados gateways. On the fly without restarting the Rados gateways. But in this example, we put the configuration and rules inside the configuration of the Rados gateways. So then we apply this service, we eventually restart the Rados gateways, and we verify the configuration. So this is the Lua script that I've made to allow for dynamic placement. You can download it and use it if you want. Regarding lifecycle rules, this is pretty easy to do. You just have to use this command which is an Amazon command, for example, here. Put bucket lifecycle configuration. So just create your own configuration and upload it on a per bucket basis. So yes, then you can check the lifecycle status, because this is a background task that runs from time to time. But you could also manually trigger the lifecycle. So manually decide to test the transition and transition objects to a new storage class. So if you want to verify dynamic placement of the data, you would have to use this debug RGW 20 so that you get to see the traces and the logs of what the Lua script does. You could also check the Rados df command and Ceph df command to check how many objects each pool has while you upload them, and when they move from one pool to another, check when that happens and what happens to the data and how much capacity it occupies in the Ceph cluster. So we'll make a demo after that if I still have some time, and then yes, based on a few like number of files of different size that I've been creating, we'll use the arclone command to send data to a bucket and observe what happens. So regarding the logs, you can see there that with a default limit of 2 megabytes 2 megabytes for the object size. For one object, which is 4.7 megabyte, you can see that no rules are matching there. So the default storage class will be applied, and the default storage class that I've made, like the storage class that I made default, is standard infrequent access, which targets an EC4+2 pool. So every object that is more than 2 megabytes will end up in this pool. And then if I upload another object which has 475 kilobytes size, which is below 2 megabytes, then the first rule will match, and in the logs you will see that the storage class standard has been applied. So it will check between the different rules, and the one having the more criteria will match and decide which storage class the object will end up in. So for this one, the applied storage class was standard. And also, when an object is uploaded with a multi-part upload, there's no way for Lua scripting to know at the moment the upload is happening to what will be the size of the object at the end of the upload. So we cannot use this information to decide whether the object should end up in a specific pool or in another one. So by default, we'll say that if it's a multi-part upload, then it will end up in a deep archive pool. So yeah, regarding optimized retention, then the idea is to monitor how the object, like how many objects are in each pool and what size they occupy. So to be able to not wait 30 days or 365 days to just make sure that your lifecycle is properly operating, you could just like use this setting, RGWLC debug interval, and set this to 1. What this will make is that a whole day will pass in a single second. So this is kind of pretty dangerous. You shouldn't use this in production, but you could still use it to at least check if your lifecycle policy and lifecycle rule applies properly. So this is what you would see in the logs when an object is transitioned. So yeah, for example, here I've been asking in the lifecycle policy, I've been asking lifecycle to transition objects at after like 15 days, so 15 seconds, and expire objects at 30 seconds. So you can see in green and blue when each rule matches. So in the first example, in the first one, we upload the object. The object is written. And then 50 seconds later at 8:13:11 seconds, we can see that the object says days 30 is expired 0, and days 15 is expired 1, which means that the file will then move to deep archive pool storage class. And when the object is deleted, it's like when the days 30 is expired 1, and then it will be deleted from the bucket. Yeah. Time for a quick demo if I still have the time. Oops, sorry. Yeah. Still there. Okay. So we have a Ceph status in the upper part of the terminal. We have the Rados df and Ceph df command playing in the middle. And then here we'll upload the data and observe the data coming into the different pools. And then, yes, we'll have this below command to run the garbage collector, because when data is transitioned from one pool to another, it's not immediately removed from the previous pool. So running the GC process will do that for us. So if I start the upload, we'll get to see new objects being created in the warm and hot data pools. Yeah, so 870 megabytes in the warm data pool and 387 in the hot data pool, depending on the object size and the limit of 2 megabytes per second, which is configurable, of course. And then you can see after 15 seconds that the transition happens, and now there's almost a gigabyte of data in the S3 archive pool. And if I run the GC command, hopefully, if not 30 seconds yet, it will only empty S3 hot and warm pool. And no, it emptied out all the, let's do this again. We'll wait for all data to be uploaded and appear on Ceph df, which is now. And then run the GC again. Oh, it will not, like, it did not transition yet. So we'll have to wait for that. Like, transition is happening. 978, transition happened. If I run the GC again, then we'll see the hot and warm data pools being emptied. Yeah. And all that data being now in the S3 archive pool. And if I run it again, then we'll see the pool being empty after all data is deleted. Yep. And all of this from Germany. That's crazy. So yeah. So I would like to acknowledge the work from, of course, Casey, Eric, and Matt, who's here today, for their long-term work on RGW. I should also probably mention Greg Farnham, which I believe is not there, and many others that have been working hard on RGW since years. I would also like to thank Yuval Lifshitz for implementing Lua scripting support in Raiders gateways, and also Matthew Eller for coding RGW compression and decompression of objects on lifecycle transition this very week. And also Stephen Mbioker from OSNixes for his work on RGW auto-tiering. Anthony Datry and Kurt Bruns talk on RGW Lua scripting. And a friend of mine, which is Laurent Barbe, also known as Kasperis, for sharing his experience on using Veeam backup and backup and replication with S3 storage the right way. So the right way is choose Amazon storage class names for compatibility reasons. Set up a standard storage class on NVMe drives for objects less in size than 64K in size. And you decide to whatever you want to do with bigger objects with a standard infrequent access storage class on HDDs or hybrid drives, for example, for objects of bigger size. And also, yeah, set the standard storage class as the default storage class. Yeah, small objects. And that's it for my presentation. Thank you. Thank you all.